Hey everyone, welcome to the section Artifacts Extraction and Analysis with CLI Tools. In the previous section, we covered the image acquisition phase of the digital forensic process. In this section, we'll focus on the extraction and analysis phase, taking advantage of the appropriate command line tools installed on Kali Linux. First, we'll take an overview of the Sleuth Kit, a set of CLI tools to analyze file systems. We will cover Reg Ripper, a tool specifically written to analyze the Windows registry. We'll also show various tools to extract and analyze browser and email artifacts, and various tools to analyze different kinds of files. Finally, we'll see how to build a super timeline with log2 timeline, Plaso. Let's move on to the first video of this section, overview of the Sleuth Kit and file system analysis. In the previous video, Introduction to Forensic Imaging, we covered the physical structure and addressing of a hard disk. We're going to recall the most important concepts about disk partitioning, volumes, and file systems. We're also going to introduce the Sleuth Kit, explaining the function of its categories of tools. Finally, we're going to show their usage to analyze the file system of an acquired image. The first sector of a hard disk is called Master Boot Record, or MBR, which contains the bootstrap code and the partition table, which contains the entries with the information about each partition on the disk. A partition can be defined as a set of contiguous sectors of the disk that are formatted with the same file system. Older computers that rely on MBR can have a maximum of 4 primary partitions, though extended partitions can be created. Newer computers that come with the Unified Extendable Firmware Interface, or UEFI, uses Globally Unique ID, or GUID, partition table that allows up to 128 primary partitions. The partition table itself is not usually of great interest to the forensic examiner, unless there are some partitions to be recovered, due to the partition table corruption. A great tool to recover partitions is Test Disk, installed on Kali Linux, which also works on raw disk images. A volume can be defined as a logical set of data formed by one or more disk partitions. A volume may even span several physical disks, while a partition can only reside on a single disk. Each volume is associated with a file system. A file system defines the storage, organization, and management of the data on the volume. Data on a file system is structured in files and directories. A file could be formed by one or several blocks or clusters, which are the smallest data units available. Generally on modern file systems, blocks have a size of over 4 kilobytes. The information associated with a file or directory is associated on 3 layers: the file name, data, and metadata. The file name stores the name of the file and the pointers to the relative metadata. The metadata contains all the other information about the file or directory, such as the owner, timestamps, permission, and the pointers to the data blocks. These are where the actual contents of the file are stored. Having introduced the fundamental concepts about disk partitioning, volumes, and file systems, let's show how to practically analyze a file system using Sleuth Kit. The Sleuth Kit, or TSK, is a suite of file system forensic CLI tools developed by Brian Carrier, one of the major experts in file system forensic analysis. It's based on part of the code of the Corners Toolkit, or TCT, created in the late 90s by Wietse Venema and Dan Farmer. While TCT can only run and be used to analyze Unix-derived OSIS, TSK is multi-platform and now supports many different file systems. It can analyze different image formats like RAW disk, EWF, and AFF images. TSK is installed by default on Kali Linux, and the latest version at the moment is 4.3.0. The tools included in TSK are divided into groups, depending on the layer on which they operate and the type of function they carry on. The prefixes of the names of the tools indicate the layers. MM is for tools that operate at the volume, media management layer. FS operates on file system structures. BLK operates at the data unit or block layer. I operates at the metadata or inode layer. F operates at the file name layer. Now the suffixes indicate their function and take the names of the respective Unix commands. For example, stat displays general information about the queried item. ls lists the contents of the queried layer. Cat dumps or extracts the content of the queried layer. There are also other tools that don't follow this naming convention. Now we're ready to analyze a file system. Now we're ready to analyze a file system, and we're going to use the image of the disk that we acquired in the video, Drive Imaging with DC3DD, from the previous section as a practical example. Remember that the image we acquired was split in 13 files, so we could ask ourselves how to deal with this issue. Don't worry, TSK tools can also work on split images. Don't worry, because TSK tools can also work on split images. The highest layer is the volume layer, and the first tool we introduce is MMLS, which displays the layouts of the partitions in a volume. We move in the directory where the split image files are stored and list the content of the directory. We then execute MMLS with the argument, which is the name of the image, followed by an asterisk, to include all the split image files. As you can see, the output shows the partition type, DOS Intel, the sector size, 512 bytes, and the partition table. The output is very similar to that of the fdisk tool, with the difference that MMLS also shows unallocated sectors of the disk, and displays the partition offsets in number sectors. In this case, we have only one partition formatted with the NTFS file system. We leave the analysis of the unallocated sectors of the disk, when we will cover file carving and data recovery. To display information about the file system, a tool with the FS prefix can help us, fsstat. From the MMLS output, we see that the NTFS file system starts at sector number 63. So we have to specify this offset with the O option. The fsstat output shows very detailed information about the file system, such as the type, volume's name, ID, OS version, and the last written, checked and mounted times. The second part of the output shows the file system's metadata. That's the location of the master file table, or MFT, the size of the MFT entries, the entry associated with root directory, which is number 5. It shows other information, such as the sector and cluster size, and below the different file attributes. The MFT contains the file system's metadata and the entries for each file and directory. These metadata are stored in special files in the root directory that begin with the symbol $, which are not visible using Windows Explorer. To list these files, we can use flstool instead. By default, it lists the root directory. The output shows one row for each file or directory. On the very left of the row, we have the file type. The R stands for regular file, while the D for directory. Next, we have the metadata address. First number on the left indicates the MFT entry. Next is the attribute type. 128 is for data, which means the corresponding files are deleted. The first 16 entries are reserved for special files, starting with $. For example, entry number 0 is the $MFT file. That stores the metadata about the MFT itself. FLS is also able to display only deleted files and to recurse into directories. To extract all the deleted entries of the file system, we execute this command. Where the P option is for also displaying the full path of each file, and the output is redirected to the deleted .txt file. There's also an M option to create a body file for the generation of a timeline with the MacTime tool. Another tool that could generate a body file is ILS. That lists the structure of the MFT entries. To display the details about a single MFT entry, we can execute the istat tool. For example, we can display the metadata of the MFT entry 0, the $MFT file. Lstat shows information such as the ownership, SID, timestamps, file attributes, and also the non-resident data clusters associated. We can also stream to the output data. We can also stream to the data output of a single cluster with the Blk Cat tool. And then pipe the output to the XXD data viewer to display the contents. Another useful tool of the block layer is Blk Ls. By default, it copies the content of all unallocated blocks of the volume. The output should be redirected to a file, and used as input for data carving tools to recover deleted files, as we'll see later in the course. The recovery of deleted files could also be done manually with the TSK tools. Finally, just a few words about the MacTime tool. It generates a timeline of a file system activity, taking as input a body file created. As we've seen with FLS and/or ILS. For example, we execute MacTime with the body file previously created with FLS. We would execute this command. We'll see another way to generate a timeline later in the course. Well done! In this video, we've covered the most important concepts about disk partitioning, volumes, and file systems. We introduced ourselves, the Sleuth Kit, explaining the function of its categories of tools, then how to use the most important ones to analyze the NTFS file system of a Windows image.